All right, welcome back, guys. Good to see you again on this channel. Today we are going to be talking about more calculations on motion, but this time around, like I promised you guys in my last video, that I was going to be talking about the vertical linear motion, and that's what we are up for right now. And let's see these questions and how we solve them. But before we get to the question, let me talk about the equations. For those that were conversant, or those that have been conversant with what we do on this channel, you would have realized that in our last physics video, we talked about equation of motion where we gave 4 equations, but this time around you are seeing 3. They have a semblance, or they look like the ones we wrote earlier, but a little bit different. And I intentionally wrote the difference in a red marker. So you could see plus and minus was an addition. You could see G instead of A, and you could see H instead of S. These are the differences, or these are the changes that we made to those equations so that we can solve vertical motion questions without stress. Just like you know before that V is final velocity, U is initial velocity, G, which has just replaced our A, is now acceleration due to gravity, T is still time, then H, which is something new that we introduced, is now the height instead of what? The distance. On the horizontal ground we have distance, on the vertical ground we have height, and that's why the S have become an H. So let's continue in this part now. See question 1. It says an object is dropped freely from rest from the top of a building. What is its velocity after 4 seconds? So that means the body was high up there, for example, like a fruit that just dropped down after being ripened or whatever. That fruit has been up there for long. It was not moving, so the initial velocity is what? 0. So we have, for question number 1, we are solving them now. Question 1, U is what? 0 meter per second. We are told that it took 4 seconds for that to happen. So our time is what? 4 seconds. We are also given, because it's under gravity, G is the acceleration, which is G equals to what? 10 meter per second square. We don't have an A. And of course, we are told to find the velocity V, final velocity with which it's going to drop. So that means the velocity with which it drops to the ground, just before reaching the ground, is called the final velocity. While the velocity with which it was released is called what? Initial velocity. I hope that is very clear. So using these equations now, you can know how to run through that. Equation 1 will just answer our question. Like you can see, that V is equal to U plus or minus GC. Well, I have something to say before we continue. Somebody is saying, so what do you now use? Is it the plus or the minus? It depends on where your object is coming from. If your object is falling from the top to the ground, that means your acceleration due to gravity is addition, that's plus. If you are throwing something upward, your G is minus. So in that case, we are using plus for this question because it's from the top to down. So we have V equals to 0 plus 10 times 4 rather, 10 times 4 in bracket. So we have 0 plus 40, and our answer is 40 meter per second. I think the answer is just waiting for us, and you can see the answer right here. To question number 2, we move. A ball is thrown vertically upward. This time around, you can see that is the reverse. Your G should be negative. The reason why, if it's not negative, the body should keep going up forever and never return. Because it's negative, it is countering that speed. It's trying to push it down backward, even though it's going up. It's trying to cancel it until it turns the speed to 0 when it starts returning back. So whatever you throw up comes down because there's what? Gravity. So, sorry, I've not finished reading my question. Number 2, a ball is thrown vertically upward with a velocity of 20 meters per second. Take G to be equal to 10 meters per second square as usual. What is the maximum height reached by the ball? So, like I said earlier, come up with all of your values. A ball is thrown upward vertically with a velocity of, so that means the first with which you threw it up was the U. So our U is 20 meters per second. Our G is what? 10 meters per second squared as usual. we are asked to find the maximum height, which is what? The h, right? But do you know that before the body will drop, will start coming back, that means it must have reached the maximum height. At that point, your final velocity should be 0. Because velocity was increasing, to keep going until velocity becomes 0, it will not return back. So if it's returning back, that means it has reached the highest height. So at highest height, at h maximum, note that at h maximum, our v is equal to what? 0. So in this case, v is 0. So we ask find what? H maximum. That's what we're looking for. Maximum height. Which can be written as just normal h if you like. So let's flow with that. We now have meter per second. So follow me and let's see which one will really work for us. So which one are we going to be using? I'm seeing my U, I'm seeing my G, I'm seeing my H, I'm seeing my V, but I'm looking for H. I think the second can do the job, if I'm not mistaken. And I think even the third can do the job. Any of these two can do. This would work, this would work. So even if you don't know your V, you will still have a beautiful work. Let's try using our second equation, that H is equal to UT plus, permit me, this is T naught plus or minus GT squared. I'm going to use the two formulas. H equal to what? Is it going to be a minus or a plus? Upward means minus, downward means plus. Upward means minus, downward means plus. So we are going upward. So it's going to be what? A minus. So we have U is what? 20. Time is what? Are we giving time? Were we giving time? Oh, sorry. This would not work because we are not giving time. Let me use my red marker to show you. You see, we got no time. No time given. So this would not work. Rather, this would work. Because the parameter time was not given in this question. So we have to use v squared equal to u squared plus or minus 2gh. Like I said, minus is our go-to. So v equal to, what's v? We don't know. Do we? We know, of course, 0 squared. Equal to, what's our u? 20 squared. What's our g? Is 10. Our h is unknown. So we have 0 is equal to 400 minus 2, minus what? 2 times 10, 20, 20h. So collect like terms. This comes here if you want to. So we have 20h is equal to 400. Divide both sides by what? By 20. So you have 20, 20, out. 2 here 1, 2 here is 20. So we have our h is equal to what? 20 meters. So that means it actually reached 20 meters before returning downward. And if you look at the option, you can guess what the option is by yourself. The option C is the right answer. So I believe we now understand the difference between the vertical component or the vertical linear motion and what? The horizontal linear motion. Promise made, promise kept. You can trust us on this channel and stay tuned and follow us as we move on to our next video. See you guys.